Okay, let me show you how to set up a model of the Clemson campus where the streams are assigned heads using the topography. So here's a air photo of the Clemson campus. The campus is right here. You can see there's some construction going on. And this is Lake Hartwell off to the east. And the area of the model will be this blue grid frame here. So I started out by going to online maps and selected this world imagery. And when I did that, I got this guy right here. And so that gives me an image that looks something like this. But what I did then was to, it takes a while for this world imagery to go out and get the data and plot it, and it takes a while to refresh. So in order to just kind of cut down on the refresh time, I went to export, and I just used the defaults here, and I said OK. And then I exported the data as a TIFF file, and I gave it a name, World Imagery Clemson Campus, right there. So I saved it like that. Well, it's not going to allow me to do it now because it already had that image. It takes a bit of time to do this, so we'll skip the step. But if you do that, then it's going to take this image, write it as a TIFF file, and then re-import it. Okay, so what I'm showing you is here is this TIFF file, and this is convenient because this plots very quickly. So that gives us a base map, and we'll also want to have the elevations. And so if we go to online maps here and scroll over to the right side, we can get the national elevation data set. This is a data set that is the topographic elevations with a 10-meter resolution. So it's in blocks 10 meters on a side. So we import that, and this is the data set right here. And then I also made a TIFF file of that. There's the TIFF file from the data set. And that's what we'll end up using to create a data file that we'll use elsewhere in the model. So if we select the TIFF file and go interpolate, actually I guess convert to, what we want to do, it's a multi-step process. So we start with this is the imported data set, and we go to export that, and then we'll re-import it as this TIFF file. Okay, and then the TIFF file we can convert to a 2D scatter point data set. So we do that and hit OK. And that gives us a different form of that data as a 2D scatter point data set. So this is it right here. And it has this format where we can't really see much, but we really don't care about plotting this data set. This is only going to be an intermediate data set. So we select it, right click, and we do convert to TIN. The TIN file is what we're going to want to use for our analysis. So we do that, and we can give it a name. Let's call it Topo 2 10. We hit OK. And then it's going to convert it to a triangular interpolated network. And that'll show up here. I already have the topography in as a TIN file. It's right there, so we're going to generate another TIN file. And you can see in this model, I already had this 2D scatter data as or the topo as a 2D scatter data right here. So I'm kind of repeating steps that I did earlier. You can see it takes a bit of time to generate this data set. There are quite a few points in the data set. It's quite a high resolution data set, so it takes a bit of time to do this. And you should keep in mind that you may have multiple tins in the file. So you can see here this file is starting to show up, this tin file. And so we'll want to be able to get access to the different ones and select them. I think what I'm going to do here is turn off the 2D scatter, and you can see now it has this name that we gave it, and it's plotting these the tin as contours on top of this color flood that is shown here as this elevation data set. So we were seeing this elevation data plotted in a couple of different ways here. Okay, so there's what the contour, the topographic contours look like. We can change what the tin looks like right here. Well, actually, what we would want to do is go up here, go to display options, and then right there, tin data, and these are contour maps. So we would select this, and here we have just the ability to change what this plot looks like. So we could reduce the line thickness, for example, there, and we would have a plot that has little finer lines, and maybe that's useful for us. I kind of like the heavier lines. You can see them a bit better, but it does get kind of muddled here, kind of close together. So we can adjust the options there. So there's what the tin looks like when it's when the lines are a little bit finer. Okay, so let's see. Now we've got the topographic data in. While we're at it, I think we're going to want to have another kind of data set, and that would be the topography as a 3D grid data. So let's see, we're okay. So to do this, we'll go to the 2D data, and we'll say, let's see, interpolate to 3D grid. So we'll select that, and this is a little bit of a cryptic name, so we'll call it topography, and hit OK. This is giving us several different types of data sets. Let's see, let's just see if, I'm not sure what that error is, but let's see, I think it should work. So we have several different data sets now. We've got the NED, we've got the 2D scatter, we've got the tin, and there's the 3D grid. Okay, and these are all the topographic surface, and we'll use them in various different ways. Okay, so this one we can reduce, and let's keep that, the topography. All right, so very good. Now let's set up the mod flow. So we're going to go and put in a new mod flow simulation, and let's just keep the defaults here. We'll check off the starting heads, and actually before we leave this, let's go to starting heads, and we're going to want to have the starting heads be the topography. So here's what we got to do. We did that a little bit premature. So we uncheck this, and then we go to starting heads, and that'll allow us to go 3D data set to the grid. And here's our 3D data set. This is why we created this 3D data set, because we wanted to use it as the initial heads. So there we go, and that sets up the initial heads to start at the topography. So now we'll hit OK. We're just going to keep all the defaults here. Okay, so now we need to set up this conceptual model, and let's go here. I've done this preliminary setup, and we need to have the recharge and the hydraulic connectivity. So I blocked off this area that we'll use for our grid and set up a coverage that has the recharge and the connectivity. And I put in some values that are just typical values for what we might find in an area. I don't know, it could be typical values for around here, 10 to the minus 6 meters per second for the hydraulic connectivity, and 10 to the minus 8 for the recharge. And now we need to set up the boundary conditions. So remember Lake Hartwell was over here. This is a little piece of the lake right there. So I put this in as a polygon, and I did that by digitizing. I digitized the polygon, something like that, and then I went to feature objects and built the polygon. So okay, so that's how I got that purple area there, and that was digitized over the area that's the lake. I'm going to erase this, and it might be useful to turn on the imagery. So there's the lake in the imagery. I guess we might want to move the lake out a little bit further to get this. We'll have grid up there, so we could edit that. I'll do that. I actually won't do that. We'll just keep on going. But we might want to do that. It's not really going to make a difference to the analysis. And then we have streams, and this is going to be really the new step. So what we're assuming is that where we have the stream and there's surface water there in the stream, that surface water is at the same hydraulic head as the aquifer would be at that point. So we'll assume that the stream is like a surface exposure of the water in the aquifer. And so the head in the aquifer is going to be equal to the elevation of the stream. And right here, we have the elevation of topography. So just as a first cut, we're going to assume that the stream is at the same elevation as the topography. And so we're going to set up these streams as a specified head boundary, and the head will be specified to equal topography. Okay, so here's how we're going to go about doing that. I'm going to turn the imagery off, and let's see. I think I'm going to. Let me see about this. Okay, so I turned off the topography that were those black lines, and now this is the tin showing up with these colored lines. And I went and digitized these lines in, and these will be constant head boundaries. So I digitized it using this feature here. And when I did it, I tried to put these lines in the stream valleys. And you can see I wasn't quite all that accurate right here, so I might want to move this over. And you can see over here it comes out of the valley a little bit. So we probably could have it be a little bit more accurate. But what I did was to run this line up the stream valley, and you can see there it goes out of the valley. So that's going to be a problem that we'll want to correct. We'll actually see these problems show up when we plot the hydraulic head, because we'll have some ripples in the hydraulic head surface that that result from this inaccuracy. So we'll want to fine tune the locations of these streams, but this will work okay for illustration purposes at this point. And so I put these in, and what I did as a first stab at this is to go and I don't really know how far upstream the headwaters are. So I put the stream here, that'll be the constant head boundaries, up to, it's about the same elevation. So it's about the light green elevation here. And I don't know, maybe this is a little bit higher. This is a little bit higher yet. But I was kind of cognizant I didn't really want to run it all the way up here. Maybe it does flow up here. Maybe there is some water in the stream up here, but this was what I used for the first cut. You know, sometimes you can get a map that has the locations of a perennial stream, but the headwaters are pretty hard to pin down, and they will actually vary seasonally as the water table goes up and down due to variations in recharge. So this is just an estimate to get us started. And then to set up this coverage, what I did was to I made it a specified head type, and I checked this layer range. And so in the attribute table, I had when I first did it, it looked like this. It was all saying none. So, and actually this one looked like this. So under the arcs, you want to make them a specified head, and under the auto assign layer, you want to, in this case, use auto assign boundary condition to one cell. And what this will do is it'll use the elevations that it gets, and it'll put the boundary condition in the right cell for that elevation. Okay, so in order to complete this, we need to go to nodes, and this is where we specify the elevation of the nodes. These little crosses here are the nodes. And so what I did was to select 10. These are all set up the same, and I did that by selecting 10. And then up here, you can see now I have two 10 files. I actually used this one. That was the first one that I imported. And I hit OK. And that then assigns all of these guys. You can, well, it should write this down, and you should see 10 in all of those. Okay, so there's the setup of the coverages. I have this other coverage here that's edge, and I'm not using that for this one. So we'll skip that for now. Okay, so now we need to have a grid, and I haven't generated a grid yet. So let's just do a real simple grid, and we're going to have to go and redo the mod flow. So that's okay. So let's go with 100 by 100, and then we'll have just one layer for this grid. This will just be a preliminary grid, and I started out the baseline at 500. This is in feet, even though it says meters. The topography, this 750, see that's in feet. So the elevation is in feet, and the model I'm going to have go from 500 to 700 feet with just this one layer. So let's go with that. And let's take a look at that. And so to turn on the grid and make it visible, I go here to cell edges, and there's the grid, and I can look at it in cross section. Here's that 10, the topographic surface, shown as kind of a projection, and then there's the grid. So for the most part, this grid that we made is underneath the topographic surface. That'll be fine for our initial model. So we lost the mod flow here. We've got to go and quickly redo that. We can go and uncheck this and put in the starting heads, and we'll go to 3D data set, and okay, so we lost the data set too, so we'll just cancel it out. We got to regenerate the data set, so we'll go up here to the 2D scatter point, convert, interpolate to 3D grid. Call it that. And so that makes this data set here in the grid, and now we can put in the mod flow, and we should be able to see starting heads, 3D data set. There's the data set we just generated. And okay, now we're ready to go. So let's take a look. Okay, so we've got our coverages, we've got a grid, we've got a mod flow, and let's try mapping this to mod flow, mapping the coverages to mod flow, and we'll turn on the grid. And turn on the mod flow so we can see. And there we go. This purple color is the, I'm going to turn off the tin now because it's getting kind of cluttered. And so the purple color is the constant head or specified head boundary. And you can see it there in the topography. So that looks like a good start. We could try doing the check simulation, see how that looks. No errors or warnings. That sounds good. So now we can go ahead and run this. So it's taking a while to save this now, and the reason for that is because this file is getting to be pretty large. These files here are large, and so I think probably it would make sense for us to delete some of these files. We don't really need them now. We need the tin for sure, but we don't need these other guys. They're just really intermediate. Okay, so it ran pretty quick, and we should have some results here that show, you can see the hydraulic head now. We can see these contours V'ing upstream in general, kinda. Here you can see it V'ing upstream, but you can also see that there are some problems. If we look up here at the headwaters, you can see it V's upstream, here it V's upstream, but then in here it's just kind of irregular. And one of the reasons for that is because we need to go and take a look at how our arc, our line is tracking up the stream valley. Up here, remember we had a problem where it kind of went off to the side of the stream valley, so that's causing some irregularities. Another thing though could be that when we have closed contours and when we see how this contour kind of V's downstream, this is the signature for a losing stream, and it's a signature for the head up here at the headwaters being too high. And so we would need to make an adjustment likely here. Well, if we wanted to keep this model and have it tuned so it was really calibrated a little bit better, then we would want to either raise the recharge or decrease the hydraulic conductivity. That would raise the head. Or if we felt like those values that we're using were okay, then this might be an indication that the boundary condition that we're using here to represent the stream is just simply too far upstream, that it's really not a gaining stream up here, that it's just dry. So if that's the case, then we would turn the tin back on and bring this downstream a little bit. Okay, so we need to do some adjustment here to get this looking right. But you can see, I guess, in this area that the stream looks, the head look pretty good, look like a gaining stream, but we just have a bit of irregularity here. Okay, so that's really the first cut. This is how we can use tin data to set up the head boundaries that represent a stream. Now there's a variety of refinements that we can do. We can make the grid conform to topography. We can refine the grid, but all of that would be then basically using the same approach that we've shown here to set up these boundaries. Okay, so you can try this and you would want to refine this. I guess there are a couple of things too that I should point out. That I guess one of the things that you want to do is always check this, and let's see, if we go and plot the heads, so we click here, and that allows us to take a look at the heads. So we want to check the range of the heads. So 632 to 682, that seems pretty reasonable. The stage of the lake is 660, and this is about 10 meters below the level of the lake, which is the elevation of the Clemson Bottoms. So that seems about right. Sometimes when you set up this this boundary condition here, when you set that up incorrectly, then one of these nodes might get skipped over. And if that's the case, the default is to set it to 0. And so you can, sometimes that's hard to spot, but if you check on the range of the heads that are being plotted, that would be a good way to spot that. Okay. So I turned the tin back on and worked on these constant head boundaries a little more. And you can see now that the headwaters here are gaining on this side. So that all looks pretty good. Right here, that's a little, that's not quite right, because see how the head is dropping and then going back up. But what happens is that the grid blocks here are about the same size as the width of the stream valley, and so this stream still goes over a little bit too far onto one side. So I could refine that a little bit. Same with right here, and so you could do some more work, but this is getting a little bit better. The one exception though is right down here. This has the telltale signs of a losing stream, because you see how the contours point downstream, and we have this bullseye, this closed contour right at the tip. So this tributary still needs some more work, and I would need to bring it down here. So this tributary probably needs to be, the headwaters need to be brought down to down about here or so. You can see that it's gaining right in here. Okay, so some refinement is needed on where the locations of the streams are, and in particular, how far up the headwaters go.